Okay, yeah, we are going to talk about Web 1.0, Web 2.0, and Web 3.0. Briefly, yes. So the Web 1.0 was basically the Amazon's era, where the popularly known what's the name of Amazon CEO? Oh yeah, that guy. So he was one of the pioneers of the Web 1.0. I'm not a big fan of him. That's why I didn't remember his name. So I'm not a big fan. So yeah, Web 1.0 was basically when he started Amazon. He was selling books, and it was a centralized server, and people could just make requests for books that they wanted, and deliveries and logistics took place. So Web 2.0 is what we are currently in. So Web 1.0 had Netscape and all of those very, very old things that I do not know about. So yeah, they mapped about they created a value of about 1.1 trillion during their era, and now we are in the Web 2.0 era. So the Web 2.0 era is the Facebook, Snapchat, and basically all social platforms that you know today. They're basically built on the Web 2.0 era, and it's literally all built on a centralized server, but they're all totally built on a centralized server. And the problem that comes with centralized servers are, some of the things I listed above, which are, shrinking economy. So these guys, what do? They collect your data, they collect my data, and they use it to do whatever they want to do, and they give you free services for it. That's why you don't need to pay subscriptions for Facebook or pay subscriptions for Snapchat and all of that. So they get to use your data for whatever they want to. So it's just like an exchange program. I was saying, what value do you have to give to the world if you have no data? So yeah, it's very sad, but most of us do not have a little bit of data of ourselves, onto ourselves, like you have your Ethereum or blockchain or Bitcoin, your private and public key to you. So your health data, you don't own it. Your transportation data, your logistics data, your name it, any data, you don't own any of them. It's being owned by the big box, Yeah. Okay. Yeah. So I don't know if you guys have seen any. Have you seen this before? Does this look familiar? Yeah. So this is the link list, and I want to give you a very big surprise that this is the solution to all the problems we seem to have. Yes, I know. This has been since the 80s, and you get the next data, and you just keep on looping and looping and looping. So now imagine this whole workflow or this whole system built on a decentralized platform, whereby it is not on a centralized server like AWS, but we have say 1,000 computers or 1,000,000 computers all running. We share this information. So let's say we want to run transactions rather than run just normal words. If you don't understand anything I'm saying, if I'm going too fast, just wave, I'll see you. Nice. Yeah. So so yeah, this is a linked list, and I don't know if I'm sure a lot of you would understand what this does. So it basically just loops information across and gets data and sends it to the next, and it goes on like that. So we want to replicate this, but rather than using words this time, we want to move transactions like this rather than just move random words. So we have so yes, I was giving you guys an analogy or an assumption of having about 1,000,000 computers. We have this set of information stored on 1,000,000 computers, distributed across 1,000,000 computers. So that way, if Amazon's office gets blown tomorrow, we don't all use our data. We have our data for distributed across 1,000,000 computers. And that way, if anybody wants to hack into the system, you have to have the powers of 1,000,000 computers to be able to hack into just one of them, because they're all working in sync. So yeah, and there are about just less than 500 supercomputers in the world right now. So say we have about 1,000,000 computers have this same information. There's no way your computer or your MacBook, whether M1, M20, would be able to break into the network. So yeah, so this is linked list, and I would just proceed to just talk about today blockchain. Yeah. So we saw the linked list, and I don't know, this looks very familiar with what we saw. So it's just like a sequence of blocks moving, but that one was nodes, but this is blocks because that's what blockchain was built on. So this is more like a senior brother to linked list. So yeah, so Satoshi woke up one day and decided to say he wanted to build an immutable system where we could like move transactions across chains, and these are called like decision trees. These are like what makes decision. In a more technical, in a more depth talk, I would have said they are called mental tags. But this is, I want to make this as simple as possible. So yes, we just replicated what we did in linked list and we put it here, and this is Bitcoin's blockchain. So basically, this is just blocks of data basically moving. But right now, we do not have. Okay, what data are we moving? We're moving timestamp. We're moving hash nodes. And all of that. So we're basically just moving transactions across blocks, and we have this on a decentralized server, not on a centralized server. Don't worry, you get to start understanding, even though you don't understand yet. So on Bitcoin, it was basically transactions moving from a block to another block, on, like I explained in linked list, where we're basically moving from nodes to another node. So this is Ethereum's blockchain. So what Ethereum did was to build on Bitcoin's blockchain, or I'm not shedding vitality here, but he basically just built on Bitcoin's blockchain. So rather than just moving transactions, we're basically not just moving transactions, we're moving timestamp, we're moving like so much information. So imagine if you could not just move random words like hello world over some blocks, but you could actually make your code live on the blocks. So you get to build a web app and you directly put it on a block, and the block is basically on a decentralized server so people could access it. So like that's the difference between Ethereum and your regular linked list, because linked list is basically Web 2.0. So this is smart contracts, and a smart contract is basically like a rule of law that basically guides the system or something. I want to like break it down to the West So to basically build anything on a smart contract, if you want to make this thing go like this and that, like the laws that exactly intricacies we want to like add to it. So we say we want to create a legal document, we want to put it on the blockchain, we want to create any form of document available, any form of document at all, we want to put them on the blockchain. We get to go through the smart contract. It's just an example code on the Ethereum. Question. Okay, so what do we want to do? We want to build web applications on a decentralized network. We want to build Facebook on a decentralized network. We want to make sure that when we are chatting, Facebook, Zuckerberg doesn't get our data. We want to own our data and still be able to do whatever we want to do on the web. Do you understand? That's basically the simple term of the whole convergence, blah, 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 that we're going to be talking about today. So to do this, we need to combine artificial intelligence, and I'll be specifically talking about deep learning here with blockchain. And the blockchain use case, the exact blockchain we're talking about is Ethereum, because Bitcoin is basically moving up, payment and transactions. But Ethereum can, live codes can basically live on Ethereum. Do you understand? Can you guys hear me? Exactly. So that's basically what we want to talk about today, and that's basically what I will explain in this very unconvincing diagram. So yes, we have Ethereum now, and we say live codes can live on Ethereum, and we have the World Wide Web. So how does this guy, everyone on the web, how do they access information on Ethereum? So now let's give an example of a project I worked on. So the project we had to it was an agricultural project, and we had like IoT devices installed on the farmlands, and we basically wanted to collect data on soil temperatures, humidity, and all of this information. So now we're saying we don't want to put it on the web, we don't want to put it on Web 2.0, we don't want AWS to have our information. Do you understand? We want to own our information by ourselves. So we decided to move to Web 3.0. So how do we do this? If we want to build on Ethereum, or if we want to put our code on Ethereum, we are going to have about 1 million people have to say approve for this information to get sent through the network. Do you understand? Before you can get to see data on your mobile phones. And that's the problem because everybody cannot happen at the same time. And this data or this data does not come in, it's not a static data, it changes because the temperature might be 30 degrees today and tomorrow it is 52 degrees Celsius. So for example, once we have APIs we want to connect from our web database from the IoT devices, we are going to implement APIs just like we do in Web 2.0 and say, okay, we want to get this data. But unfortunately, we cannot do that because of time and because of the way the Web 3.0 is being used. So we would have to implement something called the Oracle. So the Oracle is a third-party platform. I know we are not talking about third-party platforms. We are not supposed to talk about third-party platforms, but or centralized platform because it is. But they're like about I think 5 or 10 of this. But basically, what we are going to be doing is we are going to integrate the Oracle. So the Oracle gets to fetch information from Ethereum, and we can interact directly with the web. So the Oracle is like a standpoint or a middle point that basically interacts with the Ethereum blockchain, and we can basically communicate with the web in real time. So that's what the Oracle does. One of the perks of Ethereum is transparency and security. So if you are going to be doing anything on Web 3.0, there's no way to hide. That's exactly why we are running from banks. Because I didn't want to use financial institutions here because there are a lot of financial guys sponsoring this event, so they will not come for my head afterwards. But we are talking about transparency and we're talking about security. We don't want the banks to, because, okay, let me give you an instance. When we talked about the Bitcoin, we talked about transactions moving. Do you understand? We said, okay, it moves transactions across the blocks. So you can see this transaction, it is visible. But your transactions basically define your account balance in your bank account. Because if you say you transferred money, and by the end of the day, you have just about $1,000 instead of about $5,000. It is based on the transactions that, such things could happen. Do you understand? So now the transaction is visible. Nobody can tell you that, okay, yes, they own this. They could make, what do you call it? Okay, they could edit this information. Do you understand? The information is basically on the blockchain. Am I reducing my volume? Okay, yeah, I didn't want to use volume. You have a question? Okay, let me.
All right, thank you very much. My name is Liberty Oyubo. So I have a couple of questions. Number one is, so we know the way Web 3.0 works, which is hash, right? The previous block is, every block has the hash of the previous block. And if you're to move a data of 1 MB on the Ethereum network right now, it's about $17,000, just 1 MB. Now, we're looking at Web 3.0, whereby we have pictures, videos on Web 3.0. Are you saying that Oracle is able to, so is Oracle like a central server that stores all of this data?
Okay, that was a brilliant question because every day on my Twitter, I basically attack Ethereum due to their gas fees. I call it oxygen fees because, that's what they live with. So yes, to answer his question, it is not Oracle that's going to be doing this. I'm going to be explaining in the next slides how that will be done. Do you understand? So when you are sending hello to somebody and they deduct $50 and the person responds "I" with smileys and they deduct $275 because due to that time there was a lot of gas fees or a high rise of network issue. So yeah, you have a question. Go on.
My first question is, I have just 2 questions to ask, so it's a very short question. The first question is, I'm sorry I have to take you back to the previous work, is the comparison between the Web 2 and Web 3. Now we are all happy that we are moving to or diving into Web 3 because of the decentralization, right? Okay, in Web 2, we have the advantages and the disadvantages there. And the Web 3, at least the Web 3 is just like something new. We are just adapting to it. Though it may be existing before, but we are just knowing this. Some just knowing this today. Some knew this last year. At least something still fresh in the industry. Now, in your own opinion and the way you see it now, in a year to come, do you think we can undo the disadvantage of this Web 3? Yes, because I see it's like, I can't really say because it's something that is really fresh now. It's something really, really fresh. Yeah, I have my second question. Okay, the second question is that I think it was day before yesterday I was making a research on about solidity because I was trying to dive into blockchain. But to my surprise, there are not like there are no there is no much information about learning blockchain on the internet. Is there a way, or you can recommend a place where we can actually learn that conveniently? Yeah, yeah, blockchain. Yeah.
Yeah, you said that you can build apps on the blockchain on Ethereum. Now, when you build these apps, how can the end user access these apps? Is it through Play Store or is there another store where these apps can be found? Huh? Yes, yes, yes. Okay, okay, okay.
Yeah, last question. So I think that this is the issue we all have with Web3. So in the sense that if I want to host my app, I can give it to AWS and pay about $1,000. But on Web3, just look at it like I'm giving 10 people that fraction of that amount to save my data. So my question is there anything probably in your research that you have realized that this is what can change to make Web3 adoptable? Because a lot of people don't use it now. Because imagine you transferring what you already do on AWS for $1,000. Now you're doing Web3 and you're spending like times 10 of the amount. But you understand that it's more expensive to host a decentralized app than to host. Okay, tell me about that.
You're welcome. So yeah, just hold on, please. Just hold on. Let me just go through this. So yes, you talked about the problem with gas fees. You talked about the problem with unforeseen disadvantages that we are yet to see. So let's wait for this roof to fall. It won't fall before we. So yeah, we are going to definitely take measures to make sure all of this does not happen. So yes, to better explain, can you guys hear me? Yeah, to better explain how this would work, because this is just, an analogy on how we can basically get this information without delay in real time. We are going to talk about the IPFS system. So this is the interplanetary file system. So what the interplanetary file system does is basically storage. So now we can move information here in real time. We can host our code on the blockchain. We can also move information across the blockchain in real time. That's what we have discovered. Now, how do we store this information without having just one centralized server somewhere? So that's what the IPFS system does. I would explain further. Yes, so we don't need something like AWS, or we don't need Microsoft Azure anymore to basically store information now. We have the IPFS system. So what the IPFS does is to have, about you set up nodes in your houses, and, you set up a node that can take about 10 terabytes of data, and you have you in about all over the country, all over the world. You have about 1 million nodes, 10 million nodes, 100 million nodes, and all of these nodes are basically getting information. So when you want to store your information on the IPFS system, you basically just push directly, but you're not pushing to one person. So what happened is that, let me see if I made a slide to explain that better. So this is you want to basically share a file across the IPFS system. So what you do is that through the smart contract, remember when I talked about smart contracts being built on Ethereum? So through a smart contract, you basically send your file, move your file to the IPFS system. So you have one particular computer gets hold of the data, that has a copy of the data, and the data is also sent to as many computers are defined on the smart contract. So the smart contract is where each company, there are like tons of companies like the IPFS that basically does this whole thing as a service. So some of them define 23 computers to store the data, while some of them say, okay, let's have about 63 computers store the data. They have their reasons for that. So all of that are defined in the smart contract. So when you are uploading your file to the smart contract, it basically spreads around over tons of computers. So all of these computers cannot shut down a day. Do you understand? Do you guys remember what happened when AWS, had a little bit of issue with their centralized server? People whose homes were like fully run or fully run by AWS or AWS cloud services, they had their homes on lock. So if you were inside and your house was basically on the cloud, basically due to the IoT devices that you're using controlling your homes, you would not be able to go out, you'd not be able to come in if you don't have like other measures of doing that. So you have like, thumbprints and all of that. You have thumbprints, you have, all of that to basically unlock your doors. You cannot do that if you do not, if the AWS server is down. Do you understand? So our lives basically depends on these guys, and they basically use our data however they want to. So now we are saying we are not going to give these guys our data anymore, and we are going to find a better way to do this. So what are we doing? We are basically decentralizing how we store this data. So now we are saying we are storing this data to about 1 million computers shared in bits or divided. And yes, so when you want to, so what it does is that it returns an hash value to you, the user. So when you send your information, you send a file, a PDF file on the IPFS system, or you send, a database of, user information, username, email address, and all of this. Like you store your normal data on MongoDB and all of this centralized database platform. So yes, you store the information and you get an hash value in return. So an hash value is just a set key or a key of words or a key of numbers, just like you have your Ethereum address. You know how the Ethereum address are, the strings exactly. So you get that returned. So yes. So when you want to get this information from your web page, you want to fetch this data, you basically just use that particular hash key that was given to you to request for this information, and it goes directly to the central server, fetches that particular information, and sends it back to you. So we see we have solved storage. You want to?
Okay, thank you. Sorry, I just need to understand how this works. Okay, so all of these nodes on Ethereum, we have about 12,000 nodes right now. Their nodes were forked like 2 weeks back, and they lost about 7,000 nodes. Now, these nodes, they're different computers. And they're like server storage systems, right? So when you send a file, let's say the file I'm sending is not 1 MB. Let's say it's 3 terabytes. And each system or each laptop or each node can only accommodate a data of like, let's say 5 gig.
Yeah.
Right? So how do you spread 3 terabytes of data across systems that are not up to that capacity? So if you take that data and say, let's give it to the person that has the highest capacity, right? It's just one computer, and it doesn't have that it doesn't have that proof, right? You can't, yes. So so if you give it to one data center or to one node, it's centralized, right? You can't verify it with other. So that's, and second question, how do you deal with payment? So how do these people get paid? All right.
Nice. Beautiful questions. So yes, that was a very good question. So yeah, the first one was, what was the first one again? Yeah, exactly. So IPFS basically works with something called shrinking. There's something called shrinking, where the data is being shrinked. So if you are sending 10 terabytes of data, 1 billion terabytes of data, the data is being shrinked. So you're not actually sending in that capacity. The data is being shrinked and distributed across these computers. So it is not like you have your 10 terabytes here. It's not like one information is going into one computer. You have one single information being shrinked, being divided into, say, about 452 bits, and that 452 bits is being distributed to different computers. So whenever you want to request, these bits come together. That's the shrinking and unshrinking. So they come together, and they can get it to you, get it across to you. Do you understand? So it doesn't go to one computer. I mean, if it goes to one computer, that's centralization. Somebody owns your data and could cut it off anytime he wants to. Do you understand? If it's one computer, it is centralization because somebody owns your data. But this time, nobody owns the data because he cannot even access the information because the data is not being sent. So this is one thing you should know. If you send your information to a decentralized server or using the IPFS system, these people that have the computers in their houses do not get to be able to read your data. They are encrypted. Do you understand? They are encrypted. They don't even have access to it because they don't have the user information to receive these files because you need your hash key and some other keys to be able to access these files. So these guys cannot even read the information. It's just coming as some set of keys that are taking space. Do you understand? So they can't see this information. I'm coming. They can't see this information, and the information is not just on their computer. It's being shrinked into bits and distributed across tons of computers. Then you said yes. Then why should I give IPFS my computer to basically store information? Why should I give them my storage? So what IPFS did was that they built something called Filecoin. So Filecoin is the way everybody that runs a node are being remunerated. So if you basically have servers in your houses now and you set them up, if you register under IPFS or if you set up your platform with IPFS, you are going to get money based on every data that comes into your system. Do you understand? You are going to get rewarded with money. So IPFS, they have their Filecoin, and Filecoin is like a token. Do you understand? So they are paid in Filecoin tokens, and it can be traded for USDC or BUSD or whatever in any exchange platforms. Do you understand? So they get rewarded. It is not for free. So right now we're not just paying Bezos alone, but we are giving money back to everybody. So imagine your $1 being distributed to about 50 people. Let me run through the slides quickly before I go through your questions. So yes, we understand the IPFS system, and so now we have our distributed application. We have Ethereum, our codes on Ethereum as a cloud storage, and we have IPFS system as our data storage. So we have our distributed application simply built. Yeah, so let me just quickly run. So let me just give a brief run through about deep learning. So because that's the goal, or that's the reason why I'm having this topic. These are neurons. So deep learning is just basically these are like normal neurons. You all did biology in school, and I don't need to start breaking down what neurons are. So these are like normal neurons. Nobody understands. Don't worry, you're not alien. So nobody understands. These are just neurons, and like information goes through this particular thing. This thing processes information. So somebody decides to wake up one day and say, "How about I build a mathematical shall I use expression? A mathematical way of analyzing how information goes through these particular neurons that we have in our body." So these things are like do you get? So we now want to imitate what happens here through mathematics. So what happens here is that you have the way your brain processes information. Do you understand? The way your brain stores data, analyzes, then outputs information. 5 minutes. Okay, good. So, your brain keeps data, stores data, learns more from what it sees, and gets to interpret it or being able to solve solutions or, solve. I know that if I basically walk like this, I'm going to fall, I'm going to trip. And so these are things these are processes that happen. So we want to give a mathematical way, a mathematical analysis of what happens there. So I would... So what we're trying to do is to combine the IPFS system, the storage system, with Ethereum, where our hosts are, a decentralized, where you could basically build your decentralized applications with deep learning to build something very spectacular. So so we say we have your data, you have your, I have 5 minutes, I need to run quickly. You have your data, you have your, your models, your data structures, you have your smart contracts built, and we have your data. So imagine if you can, I told you from the beginning of this talk, everything is going automated, and we need data. So for example, we all have health data here, and we want to be able to do computations with our health data. We want to be able to do analysis with our health data. So we get to say, so there are organizations. So yes, so moving on to decentralizations. If there are any data scientists here, you want to move to the Web3, yeah? You want to be able to build on the Web3. You want to do things for the Web3. But the problem is that we all know that machine learning engineers get to use data, and these data are from centralized servers. So now we don't want to use centralized servers because we do not want to be able to read our information. We do not want to be able to read what they call it. So we have somebody from Falcon here. Interesting. So we have somebody from. So yes, I was saying we don't want to be able to read the information coming through or coming into the system. Okay, so we want to be able to do analysis with this data without having access to it on a web platform. And okay, I think I'm talking too much. Let me give you examples on. Yes, so I worked with a couple of platforms and a couple of projects that basically works with these three technologies: IPFS system, Ethereum, and deep learning, to build solutions on a decentralized, or to build decentralized application or distributed applications. So we do not need to read your data before we could make use of your data to run analysis or to make predictions on stuff. Yes, so the first one was algorithmia. And let me give you, that's why I made this, so you could basically understand. Okay, yeah, we have the buyer. This is built on the Ethereum blockchain, and we have the machine learning engineers all coming into place. So we have the buyers. The buyers, basically, the criteria is that you want to classify fraudulent orders, and you want to get at least 90% accuracy. So you need a sample data of about 20,000 sample order of fraudulent transactions. So you understand, you want to be able to analyze or classify fraudulent. Are there machine learning engineers in the house? Anybody, data scientists, machine learning engineers? Okay, yeah. So you want to be able to classify data, you want to be able to do analysis of data, but you do not want, okay, yeah, that's your buying request. You want to buy this data, and you are buying decentralized data. I want to buy your data, and I want to collect access from you before I get your data. Do you understand? I don't want you to give your data to Facebook for free, or to all of these, centralized platforms for free. I want to pay you money to get your data. And I know that, yes, you're a company and you have people who have run fraudulent transactions. So I want to make a request for, all of this from you. So yeah, somebody makes this request. He's going to reward anybody that can do this with $200 in Ethereum. Was going to reward people who could give him this data, $200 in Ethereum. So let's say this was an health company too. If they wanted to request blood samples from people living in Magodo, do you understand? So what they do is that everybody living in Magodo has Apple Watches. I know that's not, So everybody living in Magodo has Apple Watches, and they get to send their data to these platforms. And the collation of this data is going to get $200 in Ethereum. Do you understand? As rewards. So this data is being sent over the Ethereum blockchain. And the ML engineer basically, downloads this data and trains it based on this particular information that you have sent. Then the model is being submitted, to run on the Ethereum blockchain using this data from the contract. So you run all of these models using that particular data that you ran from the contract. Yeah. So do you guys understand that process? So now you're not. So I'm paying you to collect your data. I'm paying you to use your data. Imagine if Facebook pays you for every data that they're collecting from you. That's basically where. Thank you. So yeah, that's basically where we are moving on to. So this is one use case, and this is another use case. So this is a medical platform. What they do is, like I explained now, they get to collect your data, they pay you for your data, you have a unique identifier. If any company, any research firm wants to use your data, they have to pay, do you understand, before they could get your data. And with your data or your ID is being attached to an Ethereum address. Do you understand? So that you have a unique identifier rather than what Apple Health does with your data right now. They get to take your data, use it however they want to, and you don't get anything in reward. So yes, so right now what they do is that they built a personal healthcare system, and you have your unique identifiers. You can basically buy anything you want to. All of what are run on these platforms are basically open source. I talked about transparency as one of the most important things in the blockchain system. So yes, we have these very beautiful examples, and Yeah, I was supposed to talk about this. This is like very, very important. But basically, we have agents who are like, moving informations. And I don't think I'll be able to go deep into this because. Can you have what? Can we continue conversation? Okay, yes. I need to round up now. My Twitter is Samuel0x, and Facebook is Samuel Akinyosho. You can definitely have conversations. Facebook, I've not. LinkedIn, rather, I've not opened that platform in like years. So yes, to end my statement, why am I talking about all of this? This is Lord Future. So yes, why am I talking about all of this? Why am I being, enthusiastic about all of this? It's basically because I would live in the future. I'm still quite young, and that's where I'm going to spend the rest of my life. And I'm sure, most of us here are going to spend the rest of our lives there. So we do not want this maintenance of Meta and, all of these platforms coming to take our data and use them however they want to. We want to own our data. We want to be able to make decisions with our data. We want to be able to build decentralized applications that we would own, give power back to the people, spread the money. We don't need to have issues with people saying some companies are not paying them how they ought to be paid, because they are being earned or they are being rewarded with tokens on the decentralized. But yes, let's talk about DeFi. Let's talk about ways you could build this practically, not just theoretically like I spoke here. That's all for today. Thank you.